Hello and welcome to Chemistry with Ben. I'm your host, Benjamin Zytanner. So today what we are going to be doing is performing a solution where we take a solute and dissolve it in a solvent. And we have to find the molarity of that solute. So what we have here is a very basic setup. What we have here is the mother dish and then all of the dishes underneath it. So the very basic process that we underwent was we took and we put 1250 milliliters of water into this mother dish, and we also took and put 8 milliliters of coloring dye into it as well. Now the coloring dye color was orange. So what we have here is an eyedropper, which is approximately 1 milliliter. And in order to go through this process, what we did is we took this measuring cup here and this little dish here, and we kind of scooped it up, poured it in, and we pretty much transferred 500 milliliters of the mother solution into this next solution, and then took another 500 milliliters from water from the sink, and put it into the solution. And then we repeated this process all the way down to the final dish. Now, as you can see from a side angle is that as you go down, all of the colors change from darker to lighter. Now, this is to be expected because as you go through, you're diluting that concentration more and more and more. Now, if you come over here to see the data confirms that. So when looking at the calculations, because I wasn't working in grams, I was working in milliliters, I had to use the standard room temperature or standard room pressure conversion that I learned in chemistry. So pretty much what it is you just take milliliters and you divide it by the STP, which is 22.4, and it will give you your molarity, or your moles per mass. So what I did was I first found the moles of the original solution, so 0.8 of the red dye. And then what I did, because I was taking give or take half of each solution, is I just divided it down. So for the very first solution I got 357 moles, and then for the next one I got I got 3.57 times 10 to the negative 3 moles. For the next solution, I got 1.78 times 10 to the negative 3 moles, 8.92 times 10 to the negative 4 moles, which is in the millions place. So as and so on. But as the work reveals, is that I was able to reach the millions place. So another very important part of this calculation that I don't have drawn out for you, I believe, is these calculations also follow this formula, which is molarity times volume equals molarity 2 times volume 2. So if you take the original molarity, which is your the very first one, and the volume one, and then you stick in the second volume, what you'll find is that you're going to come out to the exact same equation. So all of the data lines up perfectly. So upon that, did I cover everything? I do believe that that is the gist of the experiment, and with all the calculations, the data lines up, and you go from a darker solution to a lighter solution. All the tools that were used were the bowls, the water, the coloring dye, which you can see right there, a calculator, some pens, highlighters, pencils, and myself, because I was thinking. And that's give or take it, along with the measuring cup right there. Well, anyways, this is Benjamin Zytanner, And this has been Chemistry with Ben.